Good afternoon. Thanks for joining us Across the Fence. I'm Fran Stoddard. The calendar says November, and despite the balmy temperatures so far this fall, we all know that snow and ice are just around the corner. And that means the use of salt on our roads. There's no doubt that salt improves highway safety and saves lives. But that lifesaver negatively impacts our environment, including our waterways. It degrades our infrastructure like bridges, and it damages our vehicles. The good news is that there are small actions we can take to limit the use of salt and to minimize its negative impacts. We learn more from UVM Sea Grant Institute.
Winters in the Lake Champlain Basin can feel very long, especially if you have to keep sidewalks and driveways free from ice and snow. The chore of shoveling, salting, and scraping might feel like an endless job. Worse yet, salt can harm the environment, wildlife, pets, and property.
Fortunately, for us and the environment, there are things that we can do to reduce the impact of salt while keeping surfaces free of ice and snow and us safe during the winter months.
Chris Stepanek is Extension Program Leader with the Lake Champlain Sea Grant at the University of Vermont.
So one of the first things you need to know is how sodium chloride, which is the most common kind of salt used for winter maintenance, does its work. So the salt is put on the surface and it hits a thin layer of water. And what happens is the sodium chloride breaks into the individual ions, sodium and chloride. And then those ions actually act kind of like referees in a hockey game. The water molecules are trying to bond together to form an ice crystal, but the sodium and chloride get in between the water molecules and they prevent those bonds from happening. So they actually depress the freezing point of water. The trick is that this only works to about 15 degrees Fahrenheit because at that point, well, there's not enough of a layer of water available to have that sodium chloride enter and then break apart into those ions.
You can put this knowledge to work in several ways. You can spread a saltwater mixture before a storm hits to reduce the ability for snow and ice to bond to your driveway or sidewalk. This makes it easier for you to shovel following the storm.
If ice and snow are in the forecast and you know the pavement temperature is above 15 degrees Fahrenheit, what you can do is take about 2.5 pounds of salt and mix that into a gallon of warm or hot water. And then you take that mixture and you put it into a garden sprayer. And then you take that and you spray thin lines of that mixture onto the surfaces where you want to prevent the buildup of the ice and the snow. And what you're essentially doing is, like you would do in a pan, you put butter in ahead of the egg, is you're preventing the bond between the ice and the surface that you're spraying this salt mixture on.
If someone else applies the salt for you, ask them to salt only in critical areas and to spread a saltwater mixture ahead of storms as described. This reduces salt use by about 25% and eases their ability to plow or shovel after the storm, saving them time and you money.
If you don't have a liquid mixture, what you can do is use dry salt. You'll use about a cup or a cup and a half per 2 parking spaces or about 10 sidewalk squares. You want to make sure that your salt grains are about 3 inches apart and also make sure that you don't have any piles. You can use a variety of handheld spreaders to help you with this and to get it spread all right. And then you also want to make sure that if you haven't spread the salt before the storm, that you shovel first and then put down the salt so you don't make it have to work its way through the snow and the ice before it can reach the surface that you're trying to keep free of snow and ice.
Following a storm, sweep up any extra salt that remains on your driveway or sidewalk so you can reuse it in a future storm. This will help keep the salt from being trapped inside your home or business and from running off in snowmelt to pollute the environment.
Each and every one of us, whether we're homeowners or business owners, have an opportunity and a responsibility to use less salt to help the environment. And one of the most important things that we can do is teach somebody else what we know so they can do it too, and the environment benefits even further.
Lake Champlain is a natural treasure. We all have a part to play in protecting it and the waters that drain to it, now and into the future. Use good winter maintenance practices the next time you apply salt to your snow-covered sidewalk or driveway. This video was produced by Lake Champlain Sea Grant, a partnership among the University of Vermont, SUNY Plattsburgh, and the National Oceanic and Atmospheric Administration. To learn more about Lake Champlain Sea Grant and to see other videos in this series, please visit our website.
Our next segment involves scientists on both sides of the lake. The scientists are working together to study a problem that is already documented in the world's oceans. Rebecca Gollin has the story.
There's a mystery in Lake Champlain.
Is it a film? Is it a bead? Is it a fiber, fragment, foam?
It is tiny pieces of plastic that researchers started noticing in the early 2000s, first in ocean waters and later in the Great Lakes and Lake Champlain.
These particles are less than 5 millimeters in size.
That's smaller than a pencil eraser.
The first project, and probably the longest running, was the wastewater treatment plant processing.
Danielle
we've been
Garneau
doing this
is a
in
professor
Plattsburgh
of
probably the
environmental
longest,
science
and then we
at
added
SUNY
on
Plattsburgh.
St. Albans.
She's leading a study investigating the distribution of the plastic particles, or microplastics, around the lake, both in the water and also in the animals who live here.
We've got invertebrates, macroinvertebrates. We've got 14 species of fish, and our top predator would be the cormorants. And so these are all the lake species we worked with, about 19 species, 14 species specifically are fish.
The research started several years ago, testing water that was treated at the local wastewater treatment facility.
We started doing wastewater treatment plant surveys at the Plattsburgh City plant. We basically will go out with a 355 micron sieve, and we'll place it under a hose that's pulling water from the last portion of processing at a plant right before it goes out into the lake.
The study recently expanded from Plattsburgh to include wastewater treatment plants in Burlington and St. Albans, with Garneau's team taking samples weekly at each location, as well as several sites within the lake.
As you can see from these pie charts, we're getting a lot of fragments. That's in orange here. And this is 2015 and 16 samples.
One concern is that accumulation of the microplastics in larger fish and predators will have a negative impact on their health.
A lot of these plastics have plasticizers and other additional additives, the BPA, and so on. And those things, are they leaching out into the other tissues, making it through the bloodstream, and impacting neurologically? And again, early findings in many organisms are showing some signs that these aren't necessarily a healthy thing for these organisms.
Another piece of the puzzle is determining exactly what kind of plastic each tiny particle came from in the first place.
There's so many thousands of kinds of plastics that are out there, different polymers, different types of plastics. Mm-hmm. Yeah, so the meander is really that S shape that rivers are going to create.
Chris Stepanuck is a professor and researcher at the University of Vermont. She's part of the Lake Champlain Sea Grant, which is funding Garneau's research on microplastics.
What Danielle is finding is that the dominant kind of plastics or microplastics in the lake are fibers. So those are coming from textiles, maybe like our fleece jackets, or from ropes or other plastic materials that are used in the lake or fishing or something like that. And then we also know that she's looking at wastewater treatment plant outfalls, and that these microplastics are making their way through the wastewater treatment plants and out into the lake.
Garneau's team is also going back to older lake water samples to figure out exactly when the different microplastics started showing up. Knowing the time frame will help them identify where some of the particles are coming from. One source researchers have pinpointed is washing machines.
One of the things that we've learned through different research studies is that different kinds of materials, and this is again the fibers being the most prevalent in Lake Champlain, When they're washed, they're shedding off pieces of plastic, and that's getting, again, through the wastewater treatment system and out into the lake.
The wastewater treatment facilities are not doing anything wrong. They're simply not set up to deal with such small particles. And while a few fibers getting free during a wash may not seem like a big deal, studies have shown that an average size load of polyester cotton blend could release an estimated 137,000 fibers. Acrylic material, one of the worst offenders, can shed over 700,000 of the microscopic plastic fibers per load.
You know, even though when we look at our sieve, when we pull it, it doesn't seem like a lot, you can imagine when we, extrapolate out to, based on flow rates and thinking about other plants that would be contributing as well, this may become a larger problem in the lake.
So, what can we do?
So what we can do is a few things. One is thinking about using fewer plastics. So what kinds of action might we have in our lives that uses plastic? We go to the grocery store. Maybe we don't use the plastic bags. Those are films, which would be called microplastic films. If a plastic bag breaks apart. She's not seeing those in huge numbers, but that's still an action we can take.
There are some products hitting the market that address the problem, like Patagonia's Guppy Friend washing bag and the Cora Ball from the Vermont-based Rosalia project. Long-term solutions could include working with washing machine manufacturers and retrofitting wastewater treatment plants to capture the smaller particles.
So in terms of what our role can be, just choosing to use alternatives or less plastic. Don't use the straws, switch over to more natural products when we're choosing face wash and toothpaste. Be a more aware consumer. That certainly is one of them. Maintenance of our outerwear and our synthetic clothing. And also, if you are out on the lake a lot, making sure that your equipment is up to speed and you're not working with frayed ropes and those sorts of things.
Solving a mystery and rethinking our relationship with the plastic we use and wear.
Can we win the war on microplastics? It's going to be challenging.
These researchers are up for the challenge and on the case. In Burlington, I'm Rebecca Gollin with Across the Fence.
And that's our program for today. Once again, thank you for joining us across the fence. I'm Fran Stoddard. Stay well.